Alrighty, we are going to revisit some exponential growth and decay, because the way we looked at it last week, whenever it was basically the way that you had seen it before. I mean, maybe you didn't do the perp form. I'm pretty sure that was probably all a review. But even though these are the same formulas, we're going to be looking for different pieces of information that would definitely be new to you because it's going to require the use of logs. Okay, so as a quick little recap, for your basic exponential growth, we have that is a function of time, where we have A, which is an initial amount, times 1 plus or minus R, depending on whether it's growth or decay, all to the t power. Okay. And then our continuous model was A equals P times E to the RT. Okay. So that's old news, not only for you in general, but we did this together not too long ago. All right, so let's look at number 1. It says, Mark started a new blog to write about his travels. In his initial week, the blog had 800 readers. From this point on, the number of readers each week, so our time is in weeks, that's important to pay attention to, increased by 25%, so there's my rate. Use an exponential growth model to find how long, so we're looking for time, it would take, and the rest of my sentence doesn't make sense. Basically, how long is it going to take to get to 10,000 people? Ignore the words that don't make any sense there. It's bad. I don't know. I think I tried to change something and I didn't realize it didn't sound right. So we're going to see, when does it reach 10,000 people? So if I'm using, so this is not continuous. This is per week, right? So I'm using this. My initial amount was 800. I'm going to multiply that times 1 plus, because it's growth. My rate is 0.25 to the t power. T is what I'm looking for. And I want to know, that amount is going to have to equal 10,000. And basically, I want to know when that happens. I got to find t for that information. Okay. So I'm solving an exponential function. I'm looking for the exponent. So I have to isolate the exponent. So I'm going to have to divide both sides by 800. So this is going to give me 1.25 to the t power equals 10,000 divided by 800. And then I can knock out 2 zeros and 2 zeros. So I get 100 over 8. You don't have to reduce that because we're going to use the calculator in the end. So it's safer to really leave it as 100 over 8 so that you just let the calculator take care of it. But I'm going to go ahead and make that into 1.25 to the t power equals, so 100 over 8 would be 50 over 4, which would be 25 over 2. Now I'm solving an exponential. I cannot get a common base. So what do I have to do? What did we do yesterday? Exactly. I'm going to take the log of both sides. That's how I'm going to get the exponent out. So I'm going to take the log of both sides. So I'm going to get the natural log of 1.25 to the t power equals the natural log. And I'm going to go ahead and make 25 over 2 into 12.5. Only because, well, for 2 reasons. I'm going to use a calculator anyway. And secondly, it's a nice pretty decimal. If it was like a repeating decimal, I'd have to leave it as a fraction because I can't round in there. So now, what happens to this t? It comes out front using my power rules. So I get t times the natural log of 1.25 equals the natural log of 12.5. Then I divide, so t is equal to natural log of 12.5 over the natural log of 1.25. All right, so I'm going to show you on this calculator, although I mean, I know you've used these calculators like a bazillion times, so you know what things look like, but how it's like different. You know, in some aspects, the other calculators that I showed you are better just because of the way it actually types in, but I know that you can type things in correctly. So natural log of 12.5 divided by natural log of 1.25. So the nice thing about the other ones that we were using, it actually makes it look like a fraction, and you can see that stuff nicely, but whatever. And this is my answer. So it says to the nearest tenth of a week. So my answer is t equals 11.3 weeks. Any questions at all? Good. Alrighty. So let's look at number 2. A new stock entered the stock market in January of 2012 at 72 cents per share. 4 years later, the price per share was $3.85. Using a continuous exponential growth model, find the growth rate. Okay, so we got lots of information here. Our continuous, that tells us we're using the PERT formula. So our principal amount, we started with 0.72. Okay, that's my principal amount times E. The rate, which I don't know, times T, which is 4. So it's going to be 4 times R up there. Equals the amount in the end would be $3.85. Okay. So I need to start by dividing both sides by 0.72. So E to the 4R power equals 3.85 divided by 0.72. So if I divide that out, that's actually a repeating yucky decimal. So I need to keep it like that and just type it in all at once. You don't get to round in the middle of a question. So now I'm going to take the natural log of both sides. So natural log of E to the 4R power equals the natural log 3.85 divided by 0.72. The 4R comes out front. And then what is the natural log of E? 1. So this really just is 1. So now I really just have 4R equals that. So now I just need to divide by 4. So R is equal to the natural log of 3.85 divided by 0.72 all over 4. So I'm going to type that into my calculator. I'm going to get, where am I? Natural log of 3.85 divided by 0.72 divided by 4. Right, so then it says that I want to find the growth rate to the nearest 100th of a percent. So what is my answer? 41.91%. Yes. 41.91%. Any questions at all? All right. So now we got a half-life. So we have a certain medicine has a half-life of 5 hours. Patient is given 500 milligrams. How long would it take? So I'm looking for time to the nearest 10th of an hour for the patient to have 100 milligrams remaining in their bloodstream. All right, so this is not continuous. I'm back to the function of time. So the initial amount is 500. I'm going to multiply that by 1 minus, because it's a half-life, and so it's a decay. And since it's half-life, it's 50%, so 0.5 to the t power, but it doesn't happen every hour, it's every 5 hours, so it's t divided by 5. And that's an exponent, even though it doesn't really look like it. And then that's going to have to equal 100 milligrams remaining. So the first thing I'm going to do is to divide by 500. So I'm going to get 0.5 to the t divided by 5 power equals 1/5. Over there, right? 100 over 500 is 1/5. What do I do now? Take the log. So when I take the log of both sides, I'm going to also use the power rule. So I'm going to kind of do 2 steps in one. This is going to give me t divided by 5 times the natural log of 0.5 equals the natural log of 1/5. Okay. So I kind of skipped a step, which is fine if you know what you're doing and why you're doing it. So now I'm going to go ahead and divide. So I get t divided by 5 equals the natural log of 1/5 divided by the natural log of 0.5. Then I'm going to multiply both sides by 5, right? So t equals 5 times the natural log of 1/2 divided by the natural log of 0.5. And then it's just up to the calculator to do the rest. Oh, 1/5. Oh my goodness, thank you. I don't know where 1/2 came from. Just wanted to see if y'all were paying attention. Now I can't change it, but okay, there we go. 1/5. Yes, you do not get to just randomly change your numbers in the middle of that. So that's going to give me 5 times the natural log of 1/5 divided by the natural log of 0.5. And this says to the nearest 1/10 of an hour. So this is going to be 11.6 hours. And I know that in Delta Math, you're not having to type in your units, but those are still important things that you have on your answer, and they still matter even though you may not have to be typing them in as part of your answer. Okay, any questions at all? All right, so now let's look at compound interest. So when we talked about this simple interest earlier, we didn't really talk about general compound interest because, again, that wasn't a brand new thing for you, and we're going to talk about it now anyway. Here's what your compound interest formula looks like. A equals P times 1 plus, so far it looks pretty much the same as the simple interest, except I'm using A and P instead of F of T and little a, but 1 plus, and then it's going to be the rate divided by N, all to the N times T power. So that's where it starts to look a little bit different. So a common application of exponential growth is compound interest. Compound interest is interest paid on both the initial investment, called the principal, and the previous earned interest. So you're earning interest on your interest as you go. So what these variables mean here, A is the total amount, P is your principal. I'm not going to, write out, that means that's your initial amount, but hopefully you know what principal means in that context. R is your rate. N is the number of times compounded. Okay. So it could be compounded, instead of like you have this interest rate per year, it might be compounded quarterly, weekly, daily, monthly, whatever. And then T is time. And most of the time, especially when we're talking interest, then this is based on years. It's like the number of times it compounds per year, and then time is time in years. I mean, you could relate this formula a little bit differently, but in general, that's what it usually means. Okay. All right, so let's look at number 6. It says if $500 is deposited, so that's my principal, and paid at an annual interest rate of 4%, compounded quarterly, how long, so I'm looking for time, will it take to the nearest year the account to reach the balance of $1,200 if there are no other deposits or withdrawals? So we have to say that because, in a lot of accounts, you'll either be putting in more money or putting in and taking out, but this is like if we just put it in there and it just sat there. There's no other variables there. All right, so my initial amount is 500. I'm going to multiply that by 1 plus the rate, which is 4%, so that's 0.04, divided by N. So if it is compounded quarterly, how many times per year is it compounded? 4. Yes, not 25 like somebody said. Yes, 25 cents is a quarter, but quarterly means it's in fourths, right? So 4 times a year times, now I'm looking for time, but the N is up here too, so this would be 4 times T. And then that total amount that we're looking for is $1,200. Okay, so that's it all substituted in. So I'm going to start by dividing by the 500. And so I'm going to simplify this. That 0.04 divided by 4 is 0.01. So this is 1.01 to the 4t power. If that was way more complicated, I could totally leave it like that and just let the calculator take care of it. And this is going to equal 12 over 5, right? 1,200 over 500. So now I'm solving an exponential. I have it isolated, so I'm going to take the log of both sides. I'm going to go ahead and bring my exponent out front. So this will give me 4t times the natural log of 1.01 equals the natural log of 12/5. Then I'm going to divide, so I get 4t equals the natural log of 12 over 5 divided by the natural log of 1.01. Then I also need to divide by 4, which really here I could have divided by 4 times the natural log of 1.01, but I need to divide by 4. So I can make it look like this. T equals natural log of 12 over 5 divided by the natural log of 1.01. So I could either multiply that by 1/4 or just divide it by 4. I'm putting it in the calculator anyway. I don't have to simplify that. Just calculator, if you use a, the kind of calculators most of you probably are using, it does the order of operations, so we're all good. So I'm going to type that in. It's going to give me the natural log of 12 divided by 5 divided by the natural log of 1.01. Just make sure that you're closing your parentheses like you should. Divided by 4. So it says, how long would it take to the nearest year? So what's my answer? 22 years. So t is equal to 22 years. Any questions at all? All right. So number 7. Dave deposited $500 into a savings account. After 15 years, the account balance had tripled with no other deposits or withdrawals. Assuming the interest compounds continuously, find the interest rate. Okay, so this is, my n basically is infinity. It's compounding continuously. It's still the PERT formula. Okay, if it's compounding continuously, it's my PERT formula. So we have an initial amount of $500 times E. The rate is what I'm looking for. Time is 15. So it's 15R equals what? I need a number over there. I can't just put a 1,500 because it says the balance had tripled. So this is 1,500. So I'm going to divide by 500 and get e to the 15r power equals 3. Now I have my exponential isolated. I'm going to take the log of both sides. So 15r times the natural log of e equals the natural log of 3. What is the natural log of e? 1. So that means that r is just the natural log of 3 divided by 15. So then I just type that in to get r. And it says to the nearest 100th of a percent. So my answer is what? 7.32%. Any questions at all? Alrighty, then you do number 8 on your own. What did you get for T? 3 years? Yes. Very good. All right. Any questions at all? Awesome.